laws of algebra of proportion. One of the laws is that an important law which said that P and P is equivalent to P. P or P is equivalent to P. Then the second law is commutative law. We state that P and Q is equivalent to Q and P. P or Q equivalents to the associative law so that P and Q and R is equivalent to P and Q and R. Then P or Q or R, P or then identity law. Then P and F is equivalent to F. Then complement law. Complement laws. You have P or negation P. You have P and negation P. Then after complement law we have double negation law. Double negation. Negation P equivalent to P. Then De Morgan's law, negation P or Q equivalent to negation P and negation Q. Negation P and Q equivalent to negation P or negation Q. These are the laws of algebra of proportion we want to use while solving simplification process. Example, the one I've just finished solving, which states simplify the following proposition. Using the laws of algebra of proposition. A is P or negation P and Q. So from the law, if you expand it, you have P or negation P and P or Q. And you say that P or negation Q is T and P or Q. Now you say that from P and whatever, T and P is P. So T and P or Q is P or Q. So that was what I did. Now the second part of the question was to simplify P or and 2 P and relation Q and Q. So from this law, this is something I'm saying Q and P and negation Q, which is Q and P and Q and negation Q. So Q and P and Q and negation Q is F. Whatever an F P and negation Q and Q. So for this other one, we want to solve so P and negation Q or Q. So that will be Q or P and negation Q. That will be Q or P and Q or negation Q. So Q or P and Q and negation Q or negation Q will be T. Whatever T and P, so you have Q or P. So that is how so if you have the third simplification law, So the third one said if you have P or Q and negation P, that will be P or negation P and negation Q. So if you have this to be negation P and P or Q, negation P and P, no, that would be P, negation P and Q, P and negation Q, P and negation P. This is F. F or P and Q. So you now have that. Then the C part. The C part of that one is you have P and Q or negation P. So this is negation P or P and Q, will be negation P or P and negation P or Q. So negation P or P is T and negation P or Q. So T and this will be negation P or Q. So those are the basic laws. What is that? I've finished it as I'm solving. So those are the laws and how to solve it in terms of algebra of proportion. So let's see how we can still solve more examples than that. So what is it? 1 to 2 minutes. Eh? So we have pathology. So if you have this to solve, to check whether it is tautology or contradiction, P or negation P and Q, you open this is and P or Q. So P or negation P or negation P is T and P or Q. Now T and P up. Some algebra proportion in logic, and so we have some laws of proportion like the idempotent law, commutative laws, associative law, identity law, complement law, and all these laws can be used. Yes, the Morgan's law, double negation law. We use most of these laws to simplify the laws of algebra of proportion, and also we use it to check a statement whether it is contradiction or is tautology. Because as you are solving it, you are going to know the end point of what you are solving. Like the one at the edge, I was solving to see, I was simplifying, and at the end of the day I have Q or P. Applying the laws in the first step, the associative law was brought into play, and at the end of the day I was able to simplify the proposition better than that. And so the next one I want to solve is still on the simplification of proposition. So The question comes this way. I want to simplify P. It is P or Q and negation P. That is example 3. So, if you have P or Q and negation P, you can rearrange that by applying the law of commutative. Commutative law can say that negation P and P or Q. So that negation P and P or negation P and Q. Are you looking for me? And I realize that negation P and P is F. Negation P and P is F or negation P and Q. And F or P is P, so F or this is negation P or Q. So we can see to it that it really helps to simplify sort. Yeah. So you need to digest this law because it really help. Like in the case of a statement being contradiction or tautology, you can use these laws to solve a lot of equations in laws of algebras of proportion. That's one that I want to solve states. Determine whether the proposition are tautologies or contradiction. So let me solve that question. So let's check whether this proposition is tautology or contradiction. Is that? So question 1, when we did question example 3, that's example 4. Checking weights, looking for tautology. And contradiction. So P or negation P and Q. This will now be P or Q, P or negation P and P and Q. So P or negation P, P or negation P, T or P and Q. So T or that is P negation P. So we have T or P or Q. This is P or negation P Now negation P is it? The last one. T-O T-O is 2. Then the second question, you have P and Q, or negation P you see we have if we split this out you have P or negation P. So we have a law that will cover up the two, which is negation P or P. That is negation in the negation P or Q. Then negation P. No, we are using the laws. So P O so that's what this one or Q. So you can simplify this now. P or negation Q and negation P or negation Q. It is going to be we will use the law of algebra proportion. So we have negation Q, we have negation Q here. So we can split. The common factor is negation Q. So we have negation Q and P or negation Q. If you open this bracket, you have negation Q or P or negation Q or negation Q. So if you have a common right of there, you can rearrange this here. Hmm? This one. You have to rearrange that inside. If you arrange this bracket, you can get the Morgan's law now. You can get distributive law. P or negation Q. P or negation Q. And negation P or Q. So this is going to be negation Q. This place can be written as what? It can be negation Q or P and negation P. This is possible. If you expand this with this, we get this. This with this, we get this.
Yes, sir.
It's possible.
Yes, sir.
So you have a negation Q. And from the law of algebra progression, P and negation P has a different ballgame altogether. P and negation P is F. So this lesson will be negation P or this is F. P and negation P is F. That place will now be F. Now or Q. And anything that is or F. Negation Q or F is negation Q. So this place will now become negation Q or Q. From the law of complement law, negation Q or Q is T. So you have proved.
Yes, sir.
That is the formula. So that one has come out. You know that laws can be used to prove whether the statement is tautology or contradiction. Whether the statement is, if I write T or F, you say the same thing. So let's check the next one that follows. We have is example 1. Now example 2 is P or Q and P or negation Q or negation P. This one here, P or Q. So you can split this to half. This one, this P or Q and negation Q. Is that possible? If you expand that, you have this will give us this for this. That will come there. So Q and negation Q. Q and negation Q is F. The other place will not be P or F or negation P. Then P or F If you see P or F, P or F, P or F is P. P or negation P. When P or negation P is true, it just becomes true. So that thing has come out steadily. Can clean that stuff. So, yes, let me give you this one. You try. That's a mind. Without the following. Mythology or contradiction. Now I want to give you something to try to check whether you are going to have tautology or contradiction. The law state P or Q and P or negation Q or can you try that? Let's see. Don't forget you are going to be applying some laws of algebra of proportion. This one. Okay. This particular one. Let me check. If that is the case, so I just gave you something that I've solved, finished solving. Let's see. Let me check. So that particular question has been solved. Okay. P and Q What's the other one? This one. So if we should try to see how to try this other one. Let's try this classwork. Let me see what you can do. We are going to apply the laws of algebra of proportion for this. Follow up the laws so that you can do accordingly. All the Morgan's law, commutative law, distributive law, associative law, those laws related to this, all of them has to be applied. Have you tried something? You see, negation P or Q. If you put negation. How do we do? If you see from the Morgan's law, you can open this. From the Morgan's law, this is going to be equals to negation into, as you want to open this bracket, the sign will change so that you have negation P or negation Q. It was and, immediately it turned to become or negation P or negation Q. Have you seen that?
Yes, sir.
So you can agree with me that whatever you see here now is what you see here.
Yes, sir.
Have you seen that?
Yes, sir.
So anytime you see a case that the logic here is the same logic there, what you do is that you now reciprocate that. P or negation P, negation outside, or if you can apply a negation outside and a negation inside, you have a case of this to simplify it. From the Morgan's law, you can have something like this. Put negation outside, then negation inside of P, that is P and Q. So if you open this, you have to open that side. Have you? So that it's going to be what? Negation into negation P or negation Q. Is that clear?
Yes, sir.
So that is when you have the other side being the same as it. So if this place is given out as negation P or negation Q, this is the same thing here. Okay? So if you call this R, this will be negation R or R. Is that clear?
Yes, sir.
Negation R or R. And negation R or R is true. So this place becomes what? True. Is that clear?
Yes, sir.
So, but this tautology and contradiction you are solving here with the law of algebra of proportion, you can also apply it using table. You can apply table to see whether what we are doing is tautology or contradiction. Let's copy this. Now let's also talk about what we call the logical equivalence. The logical equivalence now, are you through with this? We are writing this. Now, if you have a table to prepare, there's a show. That's tautology in table. If you have this proposition P and P implies Q, all implies Q, and you want to check whether it is a tautology. What you do is that, any challenge? Huh? So you can now write the table of P, write the table of Q, write the table of P implies Q. Now put the table of P and P implies Q and bring the given expression. If you let this be P, you call that P. Have you seen what I'm doing? Okay, I can call it Z. Call this place Z. So in the table you have the normal, that is the possible outcome of a table, which is always true, 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 false, false, true, and false, false. That is to say that these two statements can be true. One can be true and one is false. One can be false and one can be true, or the two can be false. Is that right? So at that point, P implies Q. P implies Q. When antecedent is true and the consequent is, it is what? Otherwise. So now, that place will now turn to what? This is true. This is what? True. This is false. This is true. This is true. So P and this, P and P implies Q, that is this and the two must be true for it to be true. Otherwise, it's what? False. And this implies Q. That is, this implies Q. True implies true. False, false is true. False, true is true. False, false is true. So what is that? Is that tautology or contradiction? Is that? Tautology, because all the elements of the output equals the word true. True, 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 all true. So we have gotten that. Are you true with that?
Yes, sir.
So, if you are given a still can I clean this side? So, is that? We are in the frequency. That's lovely. It's good to be in the frequency, be in the same page. Now let's see how we can use statements, logical statements, to, in logic, we're using logical statements and seeing the validity of a statement. You can say let P equals to this, P is, and lots more. The output, the outcome, and the behavior of everybody, because human beings differ. Human beings are irrational. Now, if I have a statement, P and Q, then I have a connectives that link the statements. It all depends on the connectives, what is included will be determined. Let's go to the statement. I want to use the primary connectives. That is statements, sentences with primary connectives. Now, let's go. It says, transcribe the following sentence into symbolic form. Transcribe the following transcribe the following sentence into symbolic form. Then A, if B is he may plays hockey. Now Q is he may plays football. And R is he may plays tennis. Then the symbolic form, then the first statement says he may plays hockey. He may play hockey, or he play football and tennis, or he plays football and tennis. Are you true with this?
Yes, sir.
I was just leaning. Lean. Now B, he is dark and tall. It is not true that if Ogun owns it's not true that if Ogun owns it is not true that if Ogun owns a radio or television, then he does not own a telephone. Radio, television. No, the question comes after this. These are statements. Question will come. The signing question comes after this. I want you to transcribe the following into symbolic form. Are you getting me now? So, he does not own a television. So, solution. Transcribe the following sentence into symbolic form. He may play hockey, or he play football and tennis. He may play hockey, or he play football and tennis. So that statement, this is how you present that. P and Q and R. How do you see that? For A. Now for B. Check that B. Is that correct?
Yes, sir.
Is that can? Now, number C. Can you try the number C for me? Just try it. Just let's see what will happen there. It is not that if Ogun owns a radio or television, then he does not own a car. It is not. Okay, it is not true. Please put truth here, please. Hello, are we together?
Yes, sir.
Yeah, it is not true. It is not true that if Ogun owns a radio or television, then he does not own a television. Negation implies negation Q. It is not true that if Ogun owns a radio or television, then he owns a television. Radio, television. Radio, television. All right. Yes. Because everybody should stand up. Just stress yourself. Stress yourself. Stress yourself. All right. That's okay. Sit down. Now let's see how we can Now let's statement with conditional and by conditional connective. statement with conditional and biconditional. Statement with conditional. So let P, Q, and R represent the sentence, while P, the trap is dry. He will win the race. Give a simple verbal which describe we are drawing this out.
Yes, sir.
Now this is what I want us to do. I have a statement there that has conditional and biconditional connectives. And now I want to give you those connectives. So you are going to give me a verbal sentence that describes the proposition. This is what I mean. For A, P, and Q. For B, then for C, which one? Now look at this. Hello. He is fast. Let me run through what I'm writing. Let P, Q, and R represent the sentences. Represent the sentences. Then P is he is fast. Q, the track is dry. R, he will win the race. He will win the race. Now give a simple verbal sentence describing a verb preposition. The preposition. Now look at that question number 1. Say P and Q or R. Huh? P and Q or R. So he is fast. So in that case, what you do is that I'm going to say if he is fast and the track is dry, then he will win the race. Do you understand? You understand? You are not saying something. See, look at this. We have conditional statement here. If P, then Q. This is the conditional statement. Are you getting me? If P, then Q. Now this other one here is a biconditional statement. Biconditional statement is when the two agree in terms, it is true. Otherwise, it's what? False. Now, I now bring in those biconditional connectives. Connectives are those symbols that are used to link two or more proposition together, a simple proposition. So now, you see at this point that I have given out the definition of terms to PQR as a simple proposition. Now, I want us to use a simple verbal sentence that describes this proposition I'm writing. Now, number 1, look at what I'm writing. I now write, if P and Q, then R. Now, you know what is P? What is P? He is fast. Q is what? The track is dry. R is what? He will win the race. Are you getting me now? So, what I want us to say is that, what would I say with respect to this? I mean the first one. I'm trying. If he is fast and the track is dry, then he will win the race. Are you getting me now? Now for the second one. P and the very simple. Okay? Is that clear now? Now look at that one. The C part of that. This has a bracket here. P. He is fast. Is it C we want to do now? C. He is fast. If and only if the track is dry or no, we're not starting from this side now. We start from here now. It is if, listen, it is if P, then Q. I guess it means. Now that one is You said that is, what is that day? I mean that day, how do you call the day? The day. There's a bracket outside here. There's a bracket outside here. So what do you do that? So that is arrangement. Yeah. Have you finished that day? So you see that a statement with conditional and biconditional connectives can be used to form a sentence directly. So very well then. All right, let's see how we can check. Now, don't forget that in a conditional statement, that is, if P then Q, it doesn't only stop there. Now we also have something like P, only if Q. Also have a statement like P is sufficient for Q. Also have a statement for the G, Q provided P. G if P. All right. Now, are you through with that?
Yes, sir.
Let's see how we can have the validity of a statement. Now, we want to find the truth value of these following statements. Finding truth value of the following statements. Finding truth value of the following statements. Finding truth value Finding the truth table, the truth value. Now find the true value. Find the truth table of the following statement. Find the truth value of the following statements. A. Nigeria is in Africa. Now look at that statement. Nigeria is in Africa. And what? Nigeria is in Africa. So I am going to show you how you do that. Then I'll give you another one to try. From that statement, if I say let P and Q represent the statements. So let's P and Q represent every two statements. Now, P is Nigeria is in Africa. P, Nigeria is in Africa. Then Q, 3 minus 2. Yes, Nigeria is in Africa. 3 minus 2 is less than 3. Now, look at Nigeria is in Africa. Is Nigeria in Africa?
Yes, sir.
So, this place is T, have you?
Yes, sir.
Is 3 minus 2 less than 3?
Yes, sir.
So, the statement is what? True. Have you?
Yes, sir.
So, when the statement is true, now do the table for P and Q. Eh? When you do a table for P, no, P and Q. Now, the statement was what? Nigeria is in Africa, and. That is and. P and Q. It is true, so what happened here now?
It's true, sir.
True, that's how we do it. That's how we roll. No, that's what I mean. No problem. Well, it have a bro. Now let's check another one. Like, if you have a mother is a woman. Now check this one. A mother is a woman and 9 is a prime number. A mother is a woman and 9 is a prime number. A mother is a woman and 9 is a prime number. So how, if you give me that? A woman is It's not a prime number. Three can divide 9. I ain't get it. Young and I go. Get this one along. Let's check another valid question. What about this be a woman? Mother is a woman. Because the two is not true. Have you? Alright, so at this point, I want to believe you understand how to find the truth value of a statement. Have you? Okay. Now, the table that I want to do now shows variation in conditional proposition. The table of now, let's see the variation in conditional proposition. Variation in conditional proposition. If you have a P implies Q, Q implies P, Q implies P, negation P implies negation Q, negation Q implies negation P. Now look at this. I have a statement that is the inverse, converse, contrapositive, of which if I link them up, I'm going to form what they call the variation in conditional proposition. Are you with me?
Yes, sir.
So, if you have a statement P, we all know that the logical statements of any logic contains the truth value. So contains what? Contains the truths, not true value, truth value. So what? Value. So you know what I mean by truth value?
Yes, sir.
What is the statement, true or false? So now, if you have this variation of conditional proposition, you are going to have a statement. The truth value of this will be true, 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 false, false, true, and false, false. Now, P implies Q here. This implies this is true, this is false, this is true, this is false. Now, Q implies P, true, true, false, Q implies P. Q implies P. F. Now negation P implies negation. Negation P implies negation Q. Not P. That's not P, that's F. F. F implies F. True now. Then you know F. Sir? You see, it is negation that we are talking about here, right? Negation P implies negation Q. This implies this. Okay, this implies this. This negation Q, that is negation Q. Q is true now. True implies false. Huh? Okay, negation P. That is false implies false. Then false implies true. It's true now. Now, true implies false. This manner. That this one was true implies false. True implies false. Then false implies false. False in. Okay, true implies true. So negation Q implies negation P. That is false implies false. Then Q, she come negation Q. That is true implies false. True implies false. Then false implies true. This one is true. Now, so you can see with me I believe we are truly. Nigeria is a country. Now we want to talk about the well-formed and parenthesis convention. So that we can get to the parenthesis part. You see, this refers to the grammatically correct symbolic expression, because logic has a lot of expression, and a well-formed formula for the proposition logic can be described that the formula is said to be well-formed. If you want to know a formula that is well-formed, first it must have an atomic formula. As if its atomic formula P, and if it's a negation of atomic formula, and if there are compound formulas like P implies Q, P if and only if Q, so let's talk about the parenthesis convention that we know, which is the connectives and symbol. Parenthesis convention. Okay, I've finished this one. Now the application parenthesis is a preposition depending on the scope of their logical connections. Now let's bring the connectives and symbols. Now if you have a table, this is a convention and logical equivalence. Now, logical equivalence. Hello? Now you have negation into P and Q, negation P or negation Q, then 2, now we have 2 negation P implies Q, comma, P and negation Q, P and Q, P or Q, P or Q implies R, Now let's look at that. If we have Francis convention and logical equivalence, the first is logical equivalence. Negation P and Q. Let's check whether it's going to give us logical equivalence as F1. We are going to use the same line but different column. Okay?
Yes, sir.
So the column so you want to do that. You now bring this out. We have P, we have P and Q. I don't want it condensed. Let me just shift it to this place. We have P, we have Q, we have P and Q, we have negation. Blank space. Q. Okay. I'm not using condenser. There's no compulsory to use condensed in this thing. What I mean is not compulsory to use condensed. It's not compulsory to use condensed now. Is it compulsory that we all use condensed? So this is TT, TF, FT, FF, and TF, FF. Now negation. Which one is negation? This. Okay, the stuff itself. That opposite was true. This is P, T, T, negation P, this is false, false, true. Negation P, false, true. This is negation Q, false, true, false, true, opposite. Now negation this or false, true, true, true. Or now. Or is it not or? It's correct now. So now, starting with logical equivalence. Is it logical equivalence? Okay? Is that correct? I don't know. It's a matter, remember. Now let's see how we can do the second one. How we can do that one. The logical equivalence. Try, let me see. Logical equivalence. The value that you're using, have you been able to get the table? Statistics man. So that's, is a logical equivalence. When the equivalence of this, you must have that value of the table of this to be the same with the other one. If not, it's not working like that. So, immediately you get that table having the same with that, we call it logical equivalence. Logical equivalence. So let's try to get that. Can we do that one? P or Q implies R. What logical equivalence of P implies R and Q implies R? Is that so? So let's see. V implies R or R implies P. We have to check that corresponding value to see what will happen. So that we can check. Let's see how it goes. P, we have P, we have Q. We have P or Q. We have P. So we're going to have PQR. It is 3. PQR. Then you have P or Q. We will have P implies R. Have Q implies R. We have P or Q. Wasn't P or Q? P implies R. P or Q implies R. Now Q. So it creates P or Q implies R. Huh? This one. You can use this one now. One, two, three, four. 1, 2, 3, 4. True. True. It's going to be true, false, true, false. Then we have that value there. So P or Q or true. Then P implies R. True, false, true, false, true. Q implies R. True, false, true. Then P or Q implies R. This implies this, okay? This implies this true. This is false. True. False. True. False. This is false. This is true. That's true. Q implies R. You have gotten that one. Okay, this one. This one and this one. You don't have this one and this one. There's this one. P implies R and Q implies R. This and this one and this one. True, false, true, false, true. Logical equivalence. Let's check whether E or they are the same. Look them all around. Hmm? All right, now you see that we have been able to get that logical equivalence. I hope you understand. So let's see how we can flow with that number one. We've done that. We've done the second one. We've done the third one. And all of them give us the same equivalence. Right? Okay. Now, but in a case we do and they are not equivalence, that's when yes, uncle. That is catching catching cold. So the tautology and the contradiction of that verb I have been able to talk to we did not talk about the mathematical induction. Sure. Okay. All right. Yes. So we need to also discuss some basic laws about mathematical induction. The principles of mathematical induction. And we know that some I have introduced guide to mathematical induction. Then the principle of mathematical induction. The principle of mathematical induction. Mathematical So some mathematical formulas or model are produced by experimental discovery. Which can be further developed for the purpose of solving problems, for them to be useful or generally acceptable. Their validity for such properties must be verified. So the principle of mathematical induction has some basic steps. Assuming we have number that is greater than or equals to 1, sum of the first odd number we apply, and 1 equals to 1 to the power of 2. Then we now try for the sum of the first two odd numbers by adding 1 plus 3 equals to 4. Then we also add some of the other odd numbers that we have. We can realize that it has a recurring value. And we may be tempted to say that the first odd number is n to the power of 2. So, if we add that up, we are going to form an equation. And the first thing we do is we set a number, then we put a constant k to the number. Then followed by the second process, put a k plus 1. Now let's see how we can apply that to solve problems. Let's consider the addition of even numbers. So the number will be 2 plus 4 plus 6, even number like that. Now we want to establish a value plus 2n equals to n into n plus 1. Because if you add 1 here, 1 into 1 plus 1, then 1 plus 1 is 2. So we now say, okay, let's Pn be the statement. Pn to be a statement. So forward. So let Pn be the statement. That statement we are writing is, okay, let's Pn be the statement. So if a Pn be that statement, therefore that my Pn will be 2 plus 4 plus 6. Then plus 2n, which equals to n to the power of n plus 1. So what we now do is that when we now form a statement, a mathematical induction statement, are you following me?
Yes, sir.
We now put n equals to 1. If you put n equals to 1, P1 will be 1 plus 1 in that particular equation. You put 1 there. In the left hand side, it's going to be 2 into 1. Now, in the right hand side will now be 1 plus 1. Have you seen that?
Yes, sir.
So if you now fix that value, you see that 1 plus 1 here is 2. 2 times 1 is what? 2. That's the left hand side, right? And 1 plus 1 is what? 2. 2 times 1 is what? 2. So what you have in the left hand side, you have, yes. So in that case, you have to establish that fact by saying that P1 is true. Are you getting me? You have to say, therefore, P1 is true. So since we have been able to get P1 to be true, you now say, okay, put n equals to k. Have you?
Yes, sir.
So we now put n, wherever you see n, we put k. You now say, for n equals to k. We are going to put k there. So, you know, the statement was Pn equals to 2n into n plus 1. So when we now say put n equals to k, this place will now be what? Pk. I mean? So that Pk in the left hand side will now be equals to what? 2 plus 4 plus 6 plus what? The wherever we see, we now put k, that place will now be 2k. Is that correct?
Yes, sir.
Equals to k into k plus 1. At this point, we call this induction hypothesis, but it's an assumption. At this point, we say assuming that P into k equals to 0. So this is known as induction hypothesis. Assuming that Pk is true is an assumption of assuming Pk, that is the value of k we put there, assuming is 0. If the assumption is that Pk is true, we now have to put Pk plus 1. Are you with me? So assuming Pk is true, then P into k plus 1 will be that place we have Pn, we now put there 2 into k plus 1 equals to k plus 1 into k plus 1. K plus 1. You open bracket. You now put k plus 1 there. Are you following me?
Yes, sir.
K plus 1. Then there's a 1 there remaining. So you have to put k plus 1 plus 1. So at that point, we have to prove this, and our approval must depend on PK, the value of PK. So the proof that is to say that PK will now be 2 plus 4 from this point plus 6, then we have 2K equals to K in the word K plus 1. So we have to add the next even number, because the next even number will determine what PK implies. So you now say, okay, add the next even number. So from that point, you see that will be 2 into K. That will be 2K plus 1 to PK. So if that happens, you are going to get P into K plus 1 equals to 2 plus 4 plus 6, then 2K plus 2, you now open back and add K plus 1, because you have to go back to the original starting point, which is here. So we now put K there, that will be now 2K plus 2K plus 1. So that will be 2K plus into 2K plus 1 will now be equals to K, then K plus 1 plus 2 into K plus 1. So from that, the right hand side should simplify. We have to simplify the right hand side. So the right hand side should be simplified to K plus 1, K plus 1 plus 1. So thus P into K plus 1 will now be equals to K plus 1 plus 2 into what? K plus 1. That's to say that K plus 1 now K plus 2, that come out right something like that, this arrow. Math-A-Thon no bag about. So from that we are going to have so since we have PK is equal to K into K plus 2, we have to expand that so that place will now give us what? K plus 1, K plus 2, which equals to K plus 1 as a common factor there. So you now have here K plus 1 plus 1 as expected, because that was our expectation. As expected. So since this is true, Since this is true, for k plus 1, we conclude that Pn is true for all natural numbers. So that is the illustration of the mathematical induction. I hope you understand. All right. Now, since we'll be able to establish that relationship in mathematical induction, let's try the second question, still on mathematical induction. I want to wipe this off. Where's the duster present? Don't worry. Don't worry. Don't worry. Don't forget we are still on mathematical induction. Now the next question is a proof by mathematical induction that 1 into 1.2 plus 1 over so by mathematical induction prove that 1 into 1.1 plus this plus 1 over n into n plus 1 for all natural numbers. For all natural numbers. So this is going to be so we now have to establish a relationship by assigning Pn to the mathematical induction program. So you now say let Pn equals to 1 into 1.2 plus 1 into 2.3 plus, so we get to n into n plus 1, which equals to n into n plus 1. So the first step there is that for step 1, you now have to put n equals to 1. So put n equals to 1. When I put n equals to 1 in this equation, I will have so we now put n equals to 1. So P1 will now be equals to, if you put 1 here, what will happen? It's going to be what? Sorry? That is P1 1 over 1, an open bracket, 1 plus 1, I mean?
Yes, sir.
1 over 1, 1 plus 1.
Yes, sir.
Is that true?
Yes, sir.
So, if you observe critically, you see that if I multiply 1 plus 1 is what? 2. So this doesn't have 1 over 1.2. That dot is multiplication. The dot is what? Multiplication. So at that point now, I now say therefore, P1 is true. Okay? P1 is true. So the next step is for me to look what we call the induction hypothesis. So it's called what? Induction hypothesis. So for step 2, so that one we assume that P, K is what? Assume P, K is true. For what? For n equals to k. Okay?
Yes, sir.
So look at that expression. There is n there. So I'm going to put k there. I'm going to put k here. Are you with me?
Yes, sir.
So therefore that means that P, K equals to what? 1 over 1.2 plus what? 1 over 2.3 plus, what are we putting there? K, have you? 1 over K. About we will get blocks. Or we will get blocks. Equals to what? K over K plus 1. So this step will be used to show that PK is true. So these steps this step will be used to show that P into K plus 1 is true. So it's an assumption. So at that point, when we put P as K, we assume Pk is true. So if Pk is true, then Pk plus 1 will be true. Have you? So you have to put Pk plus 1. So since it's an inductive hypothesis, we now say that if Pk is true, I hope you guys are following me.
Yes, sir.
Okay. If Pk is true, then Pk plus 1 will be that is K plus 1. Look at from this point. Then I'm going to put K here also. Okay? So that will be what? K plus 1 plus 1. So that is to say that every K on the right hand side is replaced by K plus 1. That is this place here. Okay?
Yes, sir.
So we now do like that. K plus 1, that is every K on the right hand side of Pk is replaced so the result can be proven thus. So if you look at that, you see that we have established something by, so you now say that the results will be proven thus. For n equals to k plus 1. Initially, we said p equals to 1. You guys said n equals to k. Now you have to put n equals to what? K plus 1. Are you there? So in that way, look at the left hand side. Look at the right hand side. So that will be then pk plus 1 will now be p into k plus 1 will be 1 from the starting point there, this place. I've introduced 1 there. So that will now be 1 into 1 dot 2 plus what? 1 into 2 dot 3. Then plus, I'm going to put k, then k plus 1 plus k plus 1, k plus 2. Now, k plus 2. That's k plus 1, k plus 1. That will be k plus 1 and k plus 1. But I'm introducing k plus 1 to the points. With this, I'm going to attach the second k plus 1 to this. So that place will now be equals to k plus 1 over k, then k plus 1 plus 1 over k plus 1, then k plus 1 plus 1. I can even write there k plus 2, it's still the same thing. Am I talking to somebody? So place k over, that is, at that point, I rearrange, I have k into what? K plus 1 plus what? 1 over k plus 1, then k plus 2. So we are going to find the LCM and disgrace that math gradually. So therefore that will be a very beautiful math. So what we have, because the LCM of this is this. So if you now break it up, you're going to have k into k plus 2 plus 1 divided by k plus 1 and k plus 2, which is equals to what? K squared plus 2k plus 1 divided by, when I expand this, I have that k plus 1 and k plus 2. So therefore, from this up, you can factorize. If factorize this up, I'm going to get something like this. K plus 1 squared, because if I expand this, I'll get this back. Have you? Yes, over k plus 1, now k plus 2. What a beautiful math. So, in that case, 1 will cancel 1. Have you? This guy here will disgrace this. And you open this to 1 plus 1. Is it not true? So this place will now be, so we now have k plus 1 all over. This place will now be k plus 1 plus 1. I mean, you can put this in a bracket. So the thing here. So there's a statement that this means. This means a very big statement mathematically. Because yara gbe can see so that man young can like okay. Ndang ni go me we go. Magari go go. So therefore, I want to believe that from that point, it therefore means that Pn is true for n equals to k plus 1. Because from there, k plus 1 had entered that place of k. So we now summarize by saying, this means that Pn is true for n equals to k plus 1 as expected, because expected and expectancy as expected. Since this is true, since this is true, since it is true for k plus 1, we now conclude. We conclude that Pn is true. Pn is true for all natural numbers of n. So that is a business. Am I communicating?
Yes, sir.
Right on that, so, we've been able to derive some certain fact on that mathematical induction. And you have, if you set n equals to 1, you have set n equals to k, you have set n equals to k plus 1. And you see, then you have what you're looking for. So let's just try one more example. Then I'll give you assignment. But okay, let me give you something you try. Let's do it together. We have an interactive session. Because the trick I never made a forest. Let's try this. Let's try it together. I think I have 5-minute interactive session with my good student. Boss, so, sure. Show by mathematical induction that 6 to the power of n minus 1 is divisible by 5. All natural numbers together equals to 1. Try that, let's see. Try that, let's see. All right, please, this is an interactive time for 5 minutes, so that I will use that time and check what you've done. So you try and solve. So please try and solve. Let's see how it goes. Let's try, let's proceed. Have you finished? We are interacting for a few minutes. Then I think I have to solve one before we have a break and come back. Let's just try something. We are interacting. Your time is draining. Your time is draining. So, just try something. Let's. All right, ladies and gentlemen, show by mathematical induction that 6n to the power of n is divisible by 5 for all now you see that the statements solution the statements Pn is Pn 6n minus 1 is divisible by 5. Divisible by 5. So step 1. Remember that for step 1, you have to put n equals to 1. Are you? So let's put n equals to 1 and see what will happen. But are you following me? P1 here, n equals to 1. P1 equals to 6 to the power of 1 minus 1. Now if you put there, 6 to the power of 1 is what? 6 minus 1. What's the answer? 5. And is 5 divisible by 5? So that's the first statement. You answer now. That P1 is what? Is true. Are you following? Since P1 is divisible, is what? Is divisible. Divisible by 5. Now, step 2 is an assumption, assuming PK is true. Huh? You are together. God bless you immediately. So, you know that P1 here, if I put P1 here, the answer is 5. This is true because it's divisible by 5. 5 over 5 is what? 1. It's divisible. So from there now, you now say, since P1 is true, now say, step 2, assuming PK is true. You know PK is an assumption. Now it's assuming PK is what? Is true. Now, then, PK will now be equals to 6k minus 1. Now, you see, we took k to that place because we assume it's true. And when we assume it's true, the way we are going to put it is that, you know that any number divisible by 5 must be multiplied by 5. Have you? Yes. So you have to write like this, 5d. You understand? That d there is an integer, a number that must multiply to 5. Are you getting me? I put this d there as an integer that is a number that will multiply with 5 to get back 6k minus 1. Are you following me? So we now say that pk equals to 6k minus 1 equals to 5d. How do we do that? Where d is what? Where d is an integer, that is a number which, when multiplied by 5 is equals to 6k minus 1. Now, the next step is what? N equals to k plus 1. First, n equals to 1. Second, n equals to k. Third, n equals to k plus 1. Have you? So, for n equals to k plus 1, in that case, this p n, which is p1, will now be what? P k plus 1, which equals to what? This place will now be also what? 6 what? K plus 1. Are you following me? See, we now have 6 into k plus 1, then minus 1. So from the law of indices, we can split this. The law of indices can split this up. The what? 6k dot 6 minus 1. Is that true? Because from the law of indices, if you write something like 6k times 6 to the power of 1, what is it? That will be 6 into k plus 1. Okay? So that place is that. So we now say but from pk equal to 6k equals to 5d plus 1. That is, from this equation, if we cross multiply, if we cross multiply, 6k will now be what? 6d plus 1. Have you seen that? So wherever I see, I will now put 6d plus 1 in that place. So coming back here, are you through with this side? I want to clear it up. Mathematics is fun. You can make a bingo, I can go and fun. So, therefore, I mean that my P, I want to replace that there. I said my PK will now be equals to, that place will now be 5d plus 1. Then bracket 6. That is, I just substitute this place. And replace it with this. Copy and paste. When I put that place, I'm going to have something of this nature. 6. It expands 6, 5d plus 6 minus 1. Because I'll open the bracket, okay? So that will be 6, 5d plus 5. So that the number 5 is common, maybe. I take 5 out, that will be 6d plus 1. Very sweet math. And this is divisible by 5 because there's 5 coming out here. So now say, so therefore the number 5 into 6d plus 1 is divisible by 5. Thus, what is it? I substitute this by there and expand. Like very tough now. The number this is divisible by 5. Thus, P into k plus 1 is true. That's what I tell you. Since P into K plus 1 is true. Therefore, Pn for all area. What do you want to do? Please, everybody, let's be on our feet. Stretch your body. Stretch your body. Raise up your hand and stretch your body. Hello. Okay. Right. Okay, be seated. Okay. We studied mathematical induction, and we want to finish up so that we can proceed to other subject topic. So today we want to start with this exercise. 25th April. April 25th. Twenty 24. Says prove that n factorials is greater into 2 to the power of n minus 1 belonging to solution. Now we have to let Pn be the statement that we want to solve. So you know, say let Pn be the statement. So the En will be n factorial that is greater than 2 to the power of n minus 1. So at this point we have to put n equals to 1. Are we together? So we put n equals to 1. That is P1. If you put 1 in n factorial, it's going to be what? 1 factorial greater than or equals to 2 to the power of 1 minus 1. which is 2 to the power of 0. So if we say that 2 to the power of 0, so with that you now say therefore P1 is true. Now if Pn is true, then Pk equals to, that is, putting Pk here, wherever we see n we put k, and so that this place will now be what? K factorial being greater than or equals to what? 2 into k minus 1. So by definition, of Pn, you see that Pk1 implies Pk1 implies k plus 1 factorial. You put k plus 1 factorial here, that will be equals to what? That is k plus 1 all factorial dot k factorial. And you know that will be greater than, let me take it up. I hope you are following. So by definition of Pn, you see that P into k plus 1 implies k plus 1 all factorial, which is equals to k plus 1 into k factorial, which is greater than or equals to k plus 1 greater than of 1 dot into 2 to the power of k minus 1 by p k, which is greater than or equals to 2 dot 2k minus 1. And from there, by implication, you know that since k plus 1 is greater than or equals to 2, it therefore means that it's greater than or equals to 2 to the power of k plus 1, then minus 1. You put k plus 1 there, which is greater than or equal to 2 to the power of k. So since this is true for k plus 1, we now conclude. We conclude that Pn is true for all n greater than or equals to 1. Let me run through this again so that you follow up very well. You see, the question was to prove that n factorial is greater than 2 into n minus 1 for all n belonging to natural numbers. And you see to it that Pn being a statement, Pn is greater than or equals to 2n to the power of n minus 1. So if you now put n 1, you see putting 1 there, that statement is true for all natural numbers. So from there we now say, okay, if P1 is true, let's say that Pk is true. So we now put K, and putting Pk implies that it is a number of natural numbers. We now introduce what? Pk plus 1. And if you now look at that, you see that with Pk plus 1, we still have k plus 1 factorial dot k, which is greater than k. And we see that it is true for k plus 1. So since we have drawn that, we now conclude that Pn is true for all n greater than or equals to 1. I believe you are following on. So we still want to do, please, hello, everyone stand up. Hello, everyone stand up. Please, just stretch yourself. No, you are not stretching yourself. See, just stretch yourself so that you can balance well in the class. All right, sit down. So, the next question, still in mathematical induction. I hope you are through with this. This is a proof by mathematical induction. That was question 1 for today. Example 2 for today says, proof by mathematical induction that 3 to the power of n plus 7 to the power of n minus 2 is a multiple of 8 for n greater than or equals to 1. Now what we do there is that we say solution. We say let Pn be the statement so if Pn be the statements, the statement now comes this way, that Pn is a number, so that you have 3n plus 7 to the power of n minus 2 and is divisible by 8. Is divisible by 8. A number that is multiple of 8 must be divisible by 8. Right? So, if you don't bring that statement down, never mean that, then P1, you now put 1 wherever we see what? And a number divisible by 8 must be a multiple of 8. Take notes. Are you hearing me? Huh? So if you have that, we substitute the value of n here, and that is the value of n here. Is that clear? The lady there. Take notes. You're not hearing me from that place. Please stand up so that you can hear me well. Stand up. Hello. I'm saying that any number that is a multiple of 8 must be divisible by 8. Because if you multiply a number, it's the number that you are dividing. So on that note we have, please keep standing. You see, if you put that value, it's going to be equal to what? 3 to the power of 1 plus 7 to the power of 1 minus 2. And 3 to the power of 1 is 3. 7 to the power of 1 is what? 7. Then, if you add this with this, or what do you have is 10. Right? If you now subtract 10 minus 2, what is the answer? 8. So therefore, P1 equals to 8. And trust me, 8 is divisible by 8. And also a very good factor of multiple of 8. So, it doesn't mean that it is what is true. For what? For P equals to what? 1. Sit down. Sit down. So it's true for P equals to 1. So at this point, we now have that is what is true. So if that is true, we have to go further. We are going to be going further by putting n equals to what? K. You have to put n equals to k. So you now say let pk will now be equals to 3 to the power of what? K. Fix up k here. Then plus what? 7 to the power of what? K. Have you seen that? Minus 2. Now what we are going to have there will be a number that is divisible or has a multiple of 8. So what we are going to have there will now be equals to 8m. M is a positive integer that is divisible by 8. So we now say where m is a positive integer. So at this point, we assume that pk is what? We assume pk is true. Okay? Yeah. So assuming that assuming that P K is true, then P into K plus 1. Now, since PK is true, we are going to put what? K plus 1. So PK plus 1 will now be this place that we started with putting n equals to 1. We now put n equals to K. Now we want to put what? K plus 1. K plus 1. So K plus 1, that will now be 3 into K plus 1 plus what? 7 into K plus 1 minus 2. So if from indices we can split this. Is that right? So this place will now be 3K dot 3 here, then plus, then you see that you can also split this, which is 7K dot, then you put the number that is divisible, then plus 4.7K minus 2. So that will now be equals to what? 3.3K plus 3.7K minus 6 plus 4.7K plus 4. Because from there, you can agree with me that minus 6 plus 4 minus 4 will give us what we have there. So this is going to be equals to 3. You know, a common factor here is what? 3, because there is 3 here. So if you now take 3 out, that place will now be 3K plus 7 to the power of K minus 2. Then plus 4. Then 7K plus 1. If you see there is 4, there is 4, there is 3, so you take it out as a common factor and bring it out. Is that clear? So at that point we can replace this with M, because this with 8, divisible factor of 8 will now be, this place will now be 3.8M. And that is what we are fixing up here. So this place is replacing that. Plus 4 into what is now left is what? 7K plus 1. So put 4 into 7K plus 1 by PK. And what you've seen here, it has really come out, which this is a multiple of 8. So say 7K is an odd number. You see that place is an odd number. That is, since 7 to the power of K is an odd number, it follows that 7 into K plus 1 is even and contains a factor of 2. So to end that up, hope you are through with this side. So to end that up, we are going to have hence 4 into 7K plus 1 equals to 8N for some integers. So it therefore means that P into K plus 1 will now be 3 not 8m plus 8n. And at this point you see that 8 is common here and here, right? And it's a common factor between 8m, the common factor here and here. So you can now take it out. You see that it's going to be 8 in the what? 3m plus what? n. So with that, we can agree that since P into K plus 1 is true, since P into K plus 1 is true, it means that Pn is true for all n greater than or equals to 1. So we have proved beyond every reasonable doubt from mathematical induction that it is true. So, madam, hello. I know very well that when it comes to mathematical induction, you always enjoy the course. It's time for me to test your ability very soon. So listen attentively to what I'm going to teach. Sit down. I did not say you should stand up. I know very well you like mathematical induction. So, hope you guys are following up very well. So that is the way we have to solve that particular question. Most respectfully. And don't forget the rules and the steps involved in finding those factors in mathematical induction. If you are given any question for you to find that, you should first of all, the steps involved is always the same. Just like what I told you before. It's first you make whatever you want to do a statement. Given a statement, the Pn equals to that statement. Then you now set n equals to 1. Are you listening to me?
Yes, sir.
You now set n equals to 1. When you set n equals to 1, now you will say that P1 is true. In that case, we put n as k, which it is known as induction hypothesis. So it's called what?
Induction hypothesis.
Not my friend down the back. I said if you put n equals to k, it's called what? Induction hypothesis. So when you now finish that, you now say k equals to 1. K plus 1. You now proceed to bring whatever you are bringing down. So we really understand how to do mathematical induction. We will now revisit this, but we have to wait in for another before we go to exercise. So please don't forget the rules. So, please don't forget that before you start you have to be sure of that it has a real value. So, we're about to touch whatever value we have as P equals to 1 in mathematical induction, we now move to P equals to K. Then from there, we move to P equals to K plus 1. As we are progressing, you flow. So, let's go back and drill the evaluation in equation. Let's be lively so that we can understand. So, we are having this equation combination of various of questions from different topics. The first one we are doing is solve the equation 7 plus 3 over 2x equals to 5x over 3. Now what we do here is that we find the LCM and the LCM of 2 and 3 is what? Is 6, right? And so since we have gotten the LCM to be 6, now you say the LCM equals to 6. So we have to do what? Multiply all through. Multiply all through by 6. So if you do that, this place will give us 7 times 6 plus 6 times 3x over 2 equals to 6 times 5x all over 3. So if you multiply 7 times 6, you are going to have 42. Is that correct? 7 times 6 is 42. Plus this, and cancel out this. 3. And if you now multiply 3 times 3x, that will give us what? Now this can cancel out this. How many times? 2. And 2 times 5 will give us 10x. So from that level we have that 42 here is equal to 10x minus 9x. What am I doing there? I subtract 9x from both sides. I subtract 9x from both sides. Hello, that's my friend there at the back. Hello? Hello? Are you hearing me? I say I have to subtract. I said I subtract 9x from both sides. What did I say? Stand up. You say? From both sides of the equation. Okay? Beautiful. So, when I subtract that, my 42, 10x minus 9x is what? That my friend there in the middle. Hello? With black top. Please stand up. 10x minus 9x is what? Say? It's x. So, that's to say that my x equals to what? 42. Is she correct? All right. So, that's question number 1. Now number 2 is two x plus 9 over 5 equals to 1 plus x divided by 5. Now from this point, the LCM solution of the denominator is what? 5. So since we have that LCM to be 5, what do? We have to multiply through by 5. Eh? Multiply through by 5. Multiply through by 5. This is going to equal to what? 5 times 2x plus 9 divided by 5 equals to 5 into 1 plus x divided by 5. Is that right? So from there you see that this 5 here will cancel out this 5. Is that true? And this, we cancel out this. So if you now cancel out like that, hello, the lady there, please stand up. Stand up. When I cancel out 5 from the using LCM, then the 5 now cancel out the 5 down. What is now left? Both in the left hand side and the right hand side. I'm not hearing you. Speak louder. 2x plus what? 9 equals to what? 1 plus x. Then from there, what next should I do? Collect like things. You are going to guide me on what to do. What you are telling me is what I do. So when I collect like things, what should I write first? 2x minus what? Minus what? Minus x. That is 2x. Is it this thing that is crossing? Okay. Minus x equals to what else? 1 minus 9. Proceed. How do we get the x? Okay, 2x minus this is x equals to 1 minus 9 is minus 8. Please put your hands together for her. That was a nice one. You are a very intelligent student. Clap for yourself. You are not clapping for yourself, you are clapping for your palms. All right. So we have the value of x to be minus 8. Most respectfully. Now let's see how we can also example 3. Example 3. Solve the system of equation using both elimination method and substitution method. Now the question is 3x plus 4y equals to minus 6 and 5x plus 6y equals to minus 8. So first, that my friend there, please stand up and read this question for me. Yo, you, the lady, read this question for me. So everybody will hear what I want to solve. Sit down, let me see her. Read this question, make it louder. I want to hear you from here. I'm not hearing you. 3x. Okay. Okay. Now, this question, we are solving it using elimination method and substitution method. So which one do you choose to solve between the two? Elimination or substitution? Okay, sit down. Look at the way I want to do this one so that you can do the next. Then to solve by elimination method first, by elimination method, solution. By elimination method, I want to eliminate either X or Y. But at this point, I choose to eliminate Y. So what I do is that I announce the equation 3x plus 4y equals to minus 6. Then 5x plus 6y equals to minus 8. So I call this equation 1. Then I multiply it with 6. And also equation 2, I multiply it with 4. The 6 here goes here, and the 4 here goes here. That is 4. Hope you are following me. Which method am I saying I'm starting with? Which method am I solving this? I said I want to solve elimination and solution. Which one am I starting with? Elimination method, right? Good. So, so if I now multiply 6, I'm going to have 3 times 6 times 3 is what? 18x plus what? 24y equals to minus 6 times is what? Minus 36. You now multiply 4. What do you have? 20x plus 4 times is what? That will be 24y equals to 4 times minus 8. Minus or that will be minus 32. So 18 minus 20 will give me this, and this is gone. Is that true? Then minus 36 plus, your minus is plus. That will give us 32 minus, that is 30. So that plus will give us minus 4. Is that right? So we have minus 4 equals to minus 4. So minus will cancel out minus. Dividing through by 2, 2x over 2 equals to what? 4 over 2. So x equals to what? 2. So since we'll be able to get the value of 2, we can now use either equation 1 either equation 1 or equation 2 to get the value of y. Are you following me?
Yes, sir.
So, and also from equation 1, 3x plus 4y equals to minus 6. For equation 1, 3x plus 4y equals to minus 6. I will now choose to substitute the value of x equals to 2 into that particular equation in order to get y. Immediately I put it there, you see, I will get the value of y. Is that clear?
Yes, sir.
So, last one. Hope you are following me. When I have gotten the value of x here. So, if I use either equation 1 or equation 2, I will still get the value of y, true or false. So, and as I put x equals to 2 into equation what? 2 or 1. Let me use 1. So 3x place of x, I will now put 2 plus 4y equals to minus 6. So 3 times 2 is what? That is 6 plus 4y equals to minus 6. So you see that this constant will cross over. And when the pluses cross, that my friend there, hello, when this 6 cross, it becomes what? When the 6 cross, it becomes minus. Are you hearing me? So minus 6 minus 10 is to minus 12. So it therefore means that my 4y will now be minus 6 minus 6. So 4y equals to minus 12. So at this point, I want to divide both sides by what? By 4. So dividing both sides by 4 give my 4y over 4 to be equal to what? So let's cancel out this. Then it cancel out, my 4 cancel to how many times? So y equals to what? Y equals to minus 3. So therefore we see that x will be equals to what? 2 and y equals to minus 3. That my friend there. Hello. Hola for me. I told you that we are starting with elimination method. Do you have any question for what I'm doing there? You don't have a question because me, I will have a question for you. Eh? Stand up. I use this method called elevation method. The first one, and I arrive at x equals to 2 and x equals to minus 3. So I still want to use substitution method now. So look at it very well. So that at the end of the day, I want you to ask me a question. I have finished with elimination method. So by substitution method, this is the elimination we've just finished. So by solution method we have solution from equation 1. I want to call this equation 1, I call this equation 2. So from equation 1, 3x plus 4y equals to minus 6. So I want to make x subject formula. You can use y. You can use any alphabet that was useful. It's not specified that you must be using x all the time. So making x subject formula here, 4y here will cross, because I will subtract 4y from both sides. Are we together? I will subtract 4y from both sides. When I do that, 3x will now be equal to minus 6 minus 4y. Then at this level, what is the coefficient? What is the coefficient of x? What's the coefficient of x here? The coefficient of x is 3. Nice one. So I divide through or divide both sides by that 3. You are following me? Eh? Are you following me? And you understand everything step by step? Because when it comes to question, I will ask you a question. So you need to follow up. Huh? You need to follow up. So I divide. I'm going to have 3x over 3 equals to minus 6. Have you seen that? So this cancel out this. So x equals to minus 6 minus 4y divided by 3. Is that right? We call that we have to call that we call that equation 3. So we can substitute, since we are using equation 2 for equation 1, to make this, we have to put it inside equation 2. Are you with me? So, and as I put equation 3 into equation what? Equation 2. I'm using equation 1 to form this. So I want to put it into equation 2. Accepted? So good friends. I can see people are discussing mathematics. When ladies are discussing maths, it's the beauty of the world. So I want to put 3 into equation 2. Wherever I see x, So you can help me do that. Yes. In your book. So that you can compare the one I want to do here. Accept it. That's a deal. So, if I not put it there, that will give us 5 into minus 6 minus 4y. Is that right? Plus 6. Y equals to minus 8. Is that correct? So you see that I can remove this fraction by multiplying through by what? Because the LCM is 3. That my friend there. The LCM, what's the LCM? What's the LCM here? What's the LCM here? 3. So since we have the LCM as 3, I will now multiply all through by 3. So now I'm multiplying through by 3. This is going to give my what? 3 times 5 into minus 6 minus 4y. Is that correct? Plus 3 times 6y. Is that true? So, now by so doing, it will cancel out 3. Is that true? Three, cancel out 3. Mathematics is fun. So I have to take time to solve it. That's one. So when you now cancel out this, we open down that bracket, okay? So we open the brackets. This place will give us minus 30, abi? Minus 20y. Is that true? Plus what? Equals to what? Minus 24. So from there we now collect like them. The minus 30 will cross. When the minus 30 cross, it becomes plus. So this place will now be minus 20y plus 18y. That's a nice one. Energy divides. Energy. So minus 20 plus 18 is 18 minus 20. That will now be minus 2y. Is that true? So minus 2y. This place will give me 30 minus 24. That will be 6. So since y has a coefficient of minus 2, I have to divide both sides by that. Okay? So I divide both sides by minus 2. So I'll get minus 2y so minus 2 cancel out minus 2. 2 cancel 600 times. Don't forget there's a minus here. So y equals to, did I have x? So I've been able to get the value of y. It's easy to get x. Okay? From equation so I now put what? Y is equal to minus 3 in the equation 3. For x, right? X will now be equal to us. So that will give us minus 6, that's plus 12 over 3. So 12 minus this one. So x is what? 3, 2. This cancel here 2 times. So therefore x equals to 2. Y equals to all right, this is time. It's interactive time. Let's everybody stand. Everybody stand. You understand? Just raise up your hand. Hello? Look at me, look at me. Like this, like this. I'm not seeing you doing that from the back. That lady. Nice. Okay. Okay. Sit down. This time for interaction. Any question? Okay. Okay. Minus one. Okay, if I multiply. Okay, come on. You still have the same answer, but it's a long thing. It's a very long process, but you have the same. So long as this one, I'm counting now, just do it. Another question. That my friend there. Hello? Call out for me. Come. I'm coming. Okay. Now look at this. Look at this. I was using solution method. Now when I was using the solution method, I come to have y to be equal to minus 3. Now when I want to find x, I put it inside equation 3. Are you hearing me? As I have used these two equations, I come and get what? Y. When I want to find x, I now use this equation. Now my question for you is that if I don't use this one, is there any other equation I can use to get x? Which equation? Equation 2 will still give me will still give me x. What about equation 1? Will it still give me? Okay. Go and sit down. And see no more mathematically. What was your question? I want to ask question.
That you have equation that looks like y equals to 5x all over x plus 3. I want to know, please, is it possible for us to have any value? You have a equation y equals to 5x over x plus 3. And you say that you want to find the solution of this equation when x equals to minus 3. Can we have the answer?
When x equals to minus 3?
Yes.
Substitute now and check. Just substitute and check. When x equals to what?
When x equals to minus 3.
What is the down value here?
X plus 3.
The down. Is it the down?
0.
No. For this equation,
Yes.
that the down, in most cases now when they evaluate the equation, they will just write a condition. And the condition is that x is not equals to that. I get it? Because if you put that value there, the equation does not exist. Are you getting me? So there are some special questions that they give, so long as the denominator they now specify that it's only on this condition that this equation does not work. Are you getting it? Any other question? Any other question? All right. Now, we've been able to solve that question using method of elimination. So we still want to use that same question, but this time around substitution method. Let's see how it goes. So, elimination method. You see, whatever method we use in equation, we still have the same answer, so long as we are sure of what we are doing. So, by substitution method, that method, as the name implies, substitution. We have to substitute one variable for another variable. You substitute x for y, or y for x. So, for equation 1, for equation 1, I want to make y subjects of formula. Now when I make y subject of formula, I will now substitute it into equation 2. Hello, you stand up. Stand up. I want you to look intensively at what I want you to solve. Because why I want you to look at it is because when I was teaching this method, you were watching it intensively. So look at it in case I do mistake, you correct me. I do any mistake, you correct me. I want us to solve together. When I say 3, you say 3 like that, so that it flow. If I solve and there is a mistake, I will hold you responsible. So I want to use solution method. So I'm using equation 1. Can we flow? So from equation 1, 3x plus 4y equals to minus 6. So I want to make y subject formula there. So what do? We are solving together. I will do 4y equals to minus 6 minus 3x. Are we flowing? So from there I now divide both sides by the coefficient of y, which is 4. So when I divide, I say divide both sides by 4. So that will give us more 4y over what? Equals to what? Minus 6 minus 3x over 4. So this cancel out this, have it? So my y will now be what? Minus 6 minus 3x. I can call that equation 3. So what should I do after that? Since I was using equation 1, I was put it into equation what? 2. Have you? Wherever I see y. So now say put what? Into equation what? Nice one. Wherever I see x. Or wherever I see y. Have you? So 5 x plus 6 into, what's my y there? Minus 6 minus 3x all over 4. Am I there? Equals to minus 8. 2 heads are better than 1. Since 2 heads are better than 1, that my friend that is there. That my friend there. And I want to make it 3 heads now. 3 heads, stand up. Let's join hands and solve this math. So from here, the LCM is 4. LCM is 4. So I have to multiply all through by 4, right? So this will be 4 times 5x equals to plus what? 4 times 6 into minus 6 minus 3x all over 4. What else? It was a minus 8 times 4. So 4 times 5 is what? So this plus will now be 20x. Let's cancel out this. Have you? So you cannot open that bracket. Is that right? If I open this bracket, this time is what? Minus this is that true? So this is minus 36. 6 times minus 3. Minus what? Beautiful. You are very smart and intelligent student. Clap for her now. Everybody clap for her. So this is going to give us minus 36. 6 times minus will now be what? Minus 36 minus 18. X equals to minus 8 times 4 is what? minus 32. Is she correct?
Yes, sir.
You see your input is very important. Smile now. So therefore, this is going to give us, we collect like terms. So that this place will now be 20x minus 18x equals to what? Minus 82 plus 36. So 20 minus 18 is what? 2x. So that 2x will now be minus 32 minus 86. So that will be 4. This is 4. So x will be 4 over 2. We have x as 2. So we are still flowing together. So from there, I want to get the value of y. So I can use equation 3. I use equation 3. So now say what? Put x equals to 2 in the equation what? Which equation am I using? Equation 3. For y. Abi? So let me take it up to this side. So if I now put that it never means that my y was a minus 6 minus 3 into my x is what? 2. So I put 2 there. Right? Divided by what? 4. So it's minus 6 minus 6. Is that true? Divided by 4. So from that point, we have minus 12 over 4. So 4 cancel minus how many times? So there's a minus here, it becomes minus 3. So see from, by solving this math with you now, it's very easy. Sit down. I will see invite you to join my channel. Next question. Sit down. So I want to be joining faith with the faith of other mathematicians in the class. I have my friend now. Very soon I want to join my faith with her. You sit down. Hello? I want to join my faith with you. So if you believe you can solve math, we can do it together. So that is together we can achieve. So we have been able to get y equals to minus 3. You can now summarize by saying, so therefore x equals to 2 and y equals to minus 3. I think that was what we had. Last one, check your work. Is that what we had when we were doing the other method? Let's interact. While solving math, we need to interact. Let's reason. Even the Bible says, come, let's. So let's reason mathematics together. Eh? Check. Let's reason. My exercise instructor. Are we reasoning maths?
Yes, sir.
I've revived the name from the spirit of it. I have to win souls in mathematics. All right. Now, let us go to equation that has 3 by 3 variables. If you have an equation that has 3 variables, that is x, y, and z, and you're asked to solve such simultaneous equation, you can apply different methods of doing this. Even though you use substitution method or elimination method or Grammar's rule, if you do your work very well and very correct, without any error, all of them will give you the same answer. Is that true? There's no one that will say, my formula is big. I was the first person that existed. So therefore my x must be 5, while your x is 2. That's my friend. That's my white yellow. Allah for it. So, we want to use question that we want to solve now. We want to solve doing different method. And now we compare the answer. But the answer will give us the same. So, and we are going to do it together. Maybe while I'm doing elimination, you can do substitution. While I'm doing substitution, you do elimination. That's how we roll. So immediately I finish one. Paul. Are we together? Oh, I hope you are enjoying mathematics. All right. Now let's start. Twin. We are in the high frequency. Our frequency is high, so at this level we need each other. We need each other. I need to get to know everybody's name so that we flow. So, candle loses nothing from lighting another candle. So we are going to solve different system of the equation solve the following equation. A 2x plus 3y minus z equals to 4. Three x plus y plus 2z equals to 18. X plus 2y minus 5z equals to minus 11. So I want to apply elimination method first. Then after elimination method, I will do solution method. Then from there, if possible, apply another method to compare. So in elimination method, what you do there is that we solve equation 1 and 2 together. So therefore, the equation is 2x plus 3y minus z equals to 4. 3x plus y plus z equals to 13. X plus 2y minus 5z equals to minus 11. So I will call solution I will call 2x plus 3y minus z equals to 4. I'll call this equation 1. I call 3x plus y plus 2z equals to 13. Equation 2. I call x plus 2y minus 5z equation 3. Then I will bring the first two equation. After that, I treat the last two. Then the remnant of the two pairs of solving, have to bring them together. That my friend there, that my friend. It is my turn now to solve this math with you. Stand up. Stand up. Yes. Together we can achieve. Now look at the three equations now. Look up. You are all mathematicians. So if you give me some ideas, let's flow. I have been able to solve this math using elimination method. So I bring the first two. Look up. 2x plus 3y minus z equals to 4. That was question 1. Have you seen that? What's your name? Oh my God. Blessing, you are going to bless this math in Jesus' name.
Amen.
So Blessing, I have that kind of name. And you never tell me. People are looking for blessing everywhere. Don't even tell me to share your blessing to others. So Blessing, I have read question 1 and 2. Look at that. Check whether the one I'm writing and the one is the same. Have you seen that? Are they the same? Question 1 and 2. Don't forget, I want to use the elimination method. Have you seen that? Good. So when I bring question 1 and 2, I want to eliminate x first. I want to eliminate x. So what is the equation of x here? 2. The equation of x here is 2. And that of x here is 3. So I have to do what? Multiply equation 1. Equation 1 times what? Equation 1 times what? The blessing is starting. Question 2 times what? Beautiful. I want to multiply for me. Now let's do it together. When I mention, you tell me the answer. 3 times 2. So that place becomes 6x. Plus, this is what? 9y. Beautiful. Then, this is what? Minus 3z. Have you? Yes, minus equals to 3 times 4. That's what? 12. Have you? Nice one. So that is 12. We have finished that one together. Now, 2 times 3 is what? 6x. Now 2 times y, 2y. Beautiful. Your blessing is flowing. 2 times 2z, 4z. So that would be plus 4z equals to 2 times 13. That's 26. 26. You see from there, I have 10 equation 1 and 2 so that this place will look alike. Have you? So I can now subtract because I want to eliminate one variable. So when I now do that, I subtract 6x minus 6x and it's gone. Beautiful. Now 9 minus 2. 9 minus 2, 7. Next one, 7y. Now look at this, minus 3 minus 4 is minus 7. We are together. That's minus 7z equals to 12 minus 26 minus, are you sure? 12 minus 26 should be minus, minus what? Minus 14. So that will be minus 14. Let me bring another marker so that you can solve. Now as I bring in marker, you have to also calculate. So I have been able to get that. See, that place is minus 14. Have you? So can I divide through by 7? Can I divide through by 7? It's possible to make it, to simplify it. So this place will be minus 14, right? So dividing through by 7. Blessing. Dividing through by 7, this place will now be what? Y minus z equals to what? Minus 2. I can call this equation 4. So I've successfully brought us y and z in that equation. So let me now bring the last two because I was using this one. This two. Beautiful. Make sure we are going to share the blessing of mathematics. So the last two, let's call the last two for me. This is going to be, this is 3x plus y plus 2z equals to 18. Now x plus 2y minus 5z equals to minus 11. Now from that point, I want to eliminate x also here. Blessing. What's the equation here? X, and this one is 1. Good. So this one will now be, this was equation 2, this was equation 3. So what's the equation here? 1. This one will be times 1 times 3. So you do the multiplication for me while I'm doing the writing. Abi?
Yes, sir.
So let me clean this place so that I have space for us. Together we can achieve. Now 1 times 1 times that will still be the same thing, Abi? If I multiply 1 with this, it's still the same thing. So I just copy and paste 3x plus y plus 2z. Now I will multiply 3. So 3 times x. 3 times 2y. 3 times minus 5. Minus 15z. 3 times minus 11. That has somebody to overtake you. Blessing. Minus 3. We now subtract, have we? We subtract. 3x minus 3x is gone. Have we? Y minus, y is just like 1. So, blessing 1 minus 6. Minus 5. Minus 5y. This is 2. This minus turn that place to plus. So 2 plus 15. That will be plus 17z equals to, this is minus. Okay? Minus is plus. So 13 plus 83. 46. So that become 46. So we've been able to get that 7y two x minus z. So you want to bring this to equation now. A blessing. I'm bringing this and this together. Good. So the first one was y minus equals to minus 2. That was equation 4. I got this equation 5. Minus 5y plus what? Equals to 46. In the first equation, here, there is no x again. Abi? In the second equation, there is no x. But from here, we are using eliminator method, so you have to also eliminate another one here. So we can eliminate y by multiplying equation 4 times 5, have you? Equation 5 times what? So 5y minus 10. This one is the same thing. Copy and minus 5y plus 17z. If we add, this place is gone. Eh? Is that true? 5 plus minus 5. 0. It is gone. Minus 5 minus 17. Minus 5 plus 17. That would be 12, have you? That is 12. Z equals to. It's just like same for 6 minus 10. Eh? Is that true? That's the same thing. What if you tell me what I take? Check. Eh? 46 minus 10. 46 minus 10. Eh? What do you tell me what I write to? Because I trust you now as a good mathematician. So from that level, you can find Z, have you? I can clean this side so that I have space. Have you? So 12z equals to 36. So you can make the same subject formula. What do we do? Divide 3 by 12, okay? So 12z over 12 equals to 36 over 12. Let's cancel this. How many times? Eh? So z equals to 3. We've gotten z. Which equation can I use to find y easily? We are still using elimination method already. I said which equation? Or what is the higher level of it? Equation 4, abi? We are using equation 4. Now say put z equals to what? 3 into equation 4. Eh? Look at equation 4 here. So y minus, that's z, I put 3. Eh? Okay? Equals to minus. So what happened there? Given us y equals to what? Are you there? So when I get y equals to what is now left? We are looking for how many variables? X, y, and z. Eh? So I've gotten z, I've gotten y. What is now left? X. So which equation can I use to get x? We are interacting. My class always interactive. Equation 3. So you now put y equals to 1, z equals to 3 for x, have you? In equation 3. Equation 3 is what? X plus it was a minus 11. So blessing, let's put now. X is what we are looking for, plus 2. Y1, put 1 y there. Eh? Minus 5, z. Okay? This one will cross. Or equals to minus a. We are looking for x. So x plus 2 times 1. Are you with me? This plus will be 2. 5 times 3, 15. Minus 15. So x 2 minus 15 is what? Minus 13. Accepted. So minus 13 will cross and become plus 13. There was minus 11 already here. So x will be equal to what? 13 minus 11 is what? So now summarize our answer. So therefore, x equals to 2, y equals to 1, and z equals to what? So we now get that are you laughing x or y was it? It is God that controls time, not man. So I'm not afraid. God's time is the base. God has taken charge. Whatever happens to remind you that God is taking control. But you also laughing. Now we have been able to get x, y, and z in that equation. That was a nice one. That was a nice one. So I want to appreciate you for a very nice companion of solving that math. Yes, official attempt. So, do we use? That's the first method we use, okay? So, sit down. I'm calling you back. That my friend at the back. Your time has come. Stand up. Stand up. Your time has come. No. Hello. Stand up. Okay. Now, just like what she was doing in this method to help me solve, you are going to be the one to help me solve this one, the second method. I was using elimination method to solve. So that same question, I want to use substitution method. She has successfully combined with me to solve. So we need each other now so that we can solve each math. So the next question is the same question. I want to clean this off so that we can do it together. So We want to see how we can solve so by substitution method, substitution method, two x plus 3y x plus 2y now you see that for equation 1, what is equation 1? I want to make the subject formula here now. Every time I've been using x, and now x has started to puff wings. So I want to use z. So the z, if you cross, if you turn from minus to what? Is that true? Good. So from equation 1, when z cross, it becomes what? What is it? 2x plus 3y. Beautiful. Z equals to 2x plus 3y minus 4. I can call that, this was equation 1, this was equation 2. So I've been able to make Z subject formula now. So since I'm using equation 1 to make Z subject formula now, so I have been able to get that. So I want to put it into equation what and what now? Equation 1. 2 and you are very smart. I say you are flowing. You have people like this, I'm suffering. But I'm going to the board to help me now. So you put from 1, put this into equation 2 and 3. So that will give us, whenever we see it, we put that. So that will be 3x plus y, plus what? 2 into, I replace that. So it's going to now be what? 2x plus 3. Is that true? Yeah. 3x plus y plus, open that bracket. Tell me now. Minus 8. Right? Now, this and this, that'll be what? You add 3x plus 4x, what do you have? Then y plus c will now be what? Then equals to 18. This one will cross and becomes what? Eh? So 7x plus 7y. What's 13 plus 8? You can divide 12 by 7. That will give more what? I'm asking you. That will give me what? I divide 12 by 7. Plus. Equals to what? You can call that equation 4. I mean, let me call this 4. Or that 5. See how you are flowing. From what we've done there is no Z anymore. Eh? Right? So now I want to put from equation 1, I put it in 2. Eh? I want to put it in 3. This place was put Z into 2. Eh? Put it into 2. So now I want to put it into 3. Right? So put Z into 3. So this 3. X plus 2y. What do I do? Minus 5. Huh? So open a bracket. Was it equals to what? What was that? Girl is good. So this is x plus 2y. Open this bracket. Now 15y. What's the minus 11? Okay? So these are like them. X minus 10 minus 9x. Okay? 2 minus 15 minus what? Now minus 11 is here. This will cross. Is that right? Eh? So that will be minus 9x minus 13y equals minus 11 minus 20. Eh? Minus what? Check, is there anything I can divide through? Minus 1. Okay. So multiply by minus 1. So that was other equation 6. So I'll bring two of them together, I'll marry them. Huh? Because in the initial point here, There was no Z is nowhere to be found here. So bring in this one. I have been able to get in that equation. What do I do next? Then what? In equation 5, I'm putting into equation 6 because we're still in substitution method. Very smart. So from there we have that equation 5, x equals to 3 minus y. Now we want to put it in this put equation 7 into equation 6. Is that true? So that place will now be what? Three minus y, okay, me spiritually. So we are together. So this, where do we have the 7? Is it 27? Okay. Minus what? Is that right? So we now collect like terms, okay? Can we add this with this? Minus 9 plus 13, okay? So let's say 13 minus 9. What do we have? This one 31 here, this one will cross. 31 minus, what's the answer? Twenty-seven, 28, 29, 30, 31. So 4y is that true? Now we've gotten y. Which equation can we use? We've gotten y. Which equation can we use to get x easily? Equation. So from 7, x equals to 3 minus 1. Have you? Eh? What is that? This is why I need you. If none of them would have done that mistake. So what else? With x and y, which equation can I get? Well, which variable can I get easily? Equation 4. So put x equals to 2, y equals to 1, 4, z, have you? In equation 4. Do like this. So z equals to what? Two into 2, have you? So therefore z and that's what? Eh? Now what is left? Is that what is left? Is that what is left? Last one. Come here again, bring me that book. Carry me that book. Bring me the book. Bring me the book. Thank you, man. God bless you, man. God bless you. See, you turn like this and come. Turn like this and come back to your seat. So you'll be able to get x as 2, y as 1, z. So you have been able to get that. So the one we were solving was the one we were solving was 2x plus 3y. Now with that, I think we have the same answer with the other one. All right. So therefore x equals to 2. All right, now let's go. Sit down. That is the value of x, y, z using that substitution method. So now I want to use Grammar's rule. Use Grammar's rule to solve that. So now, I've been able to get the value of x I've been able to solve the value of x, y, and z using two methods now. Which method of measure did I use? Which method of measure did I use? I have used substitution method and elimination method. Are you getting me? So now I want to use Grammar's rule to solve that same equation. I think I should give time for question. All right. Please, any question? Please ask question. Huh? Yes. What is that? Yeah. Let me see the equation. Thank you. All right. Let me see the equation. X, 2x plus y equals to 7.
Yes, sir. And x plus 2y equals to 4.
This one is separate.
Then equals x plus y.
You solved something like this before now. Have you tried solving this? Okay. All right. Let's run this. All right, let's see how we are going to do this together. I believe you are through with the one in the board. Yes. So we have 2x plus y equals to 7. X plus 2y equals to 4. That equation, x from my suspects, x will be 0 and y will be 0. Okay? But let me just solve and check. X is 0 and y is 0. Let's check. Now, times 1 times 2. 2x plus y equals to 7. 2x plus 4y equals to what? 8. It is gone. Y minus this what? Minus 3y equals to minus 1. Y equals to what about 3 now? Eh? You now substitute and get x. It's not a big deal. Eh? Is there any other objection? Eh? Okay, what if it? Okay. Any other question? Yes. Okay. So, time is gone. Please, we want to solve The next method I want to use is Grammar's rule. Now Grammar's rule uses the idea of matrix. So that we now bring in the equation, and also when we bring the equation, we find determinants of the original equation that was given. And now we now find that for us to get the value of x, we put the solution, there. We now put the solution in the x row. When we now do that, we find determinants of that and divide the original determinants by the first determinant we got when we were solving with the system of the equation. So after that, we also want to find the value of y. We do the same thing. And when we now do the same thing, we do the same thing for the corresponding value of z. So that will really help us to get the value of x, y, and z respectively. So let's start. I will give you an highlight of what to do so that we can do it together. Don't forget that mathematics is fun. So let's get the fun together. Energy. So we bring in the values of what we want to solve. If we now put those values in, we have two x plus 3y two x plus 3y three x plus y plus 2z equals to 13. X plus 2y minus 5z equals to minus 11. And these are This is the equation we are going to use. So long as we have that three variable x, y, and z, we should so what we are going to do there is that we try as much as possible to find the corresponding value of x, y, and z. One by one, so that when we get x, we get y, and we get z. So let's start. So now this is 2x plus 2y minus z equals to 4. Now you can agree with me that no matter method that we use, we're still going to have the same answer. So we are using Grammar's rule. So in Grammar's rule, we are going to bring in the coefficients of x, y, and z respectively. So what is here? We have x. What's the coefficient of x here? What about here? 1. What about this one? Minus 1, 2, and what? Have you seen that? Now, you now bring in what? X, y, and z. Bring the constant value, which is what? 4, 18, and minus 11. Have you seen that? So when we now do that, that is the first step we do in order to solve using Grammar's rule. So we now select those coefficients we brought out. We assign a number to it. Are you following me? So I select A equals to that. I want to call it a matrix name to it. So I call it A. So say let A equals to 2, 3 minus 1, 3, 1, 2, 1, 2 minus 5. So I want to find the determinant of A. I want to find the determinant of A. How do I find the determinant of A? I use the cofactor So when I find the determinants, I can call this plus, minus, plus. So I bring in 2. I want to find determinant of A. So when I bring 2 out, what is in the row of the 2? And the column we don't need. So what do we have? 1, 2, 2 minus 5. Now, what do I have here? Minus 3. I take minus 3 out. What I have in the row of minus 3 and the column is not needed. So what do I have? 2, 3, 1 minus 5. This place. The row and the column. 3, 2, 3, 2, 1 minus 5. This one is minus 1. When I put minus 1 out, what do I have? 3, 1, 1, 2. 3, 1, 1, 2. Are you there? So, you know, 2 into, this was minus 5, right? Minus 5. So, find the determinant of 2 by 2 now. When I cross this, that will be what? Minus 5 minus 4. Is that correct? Yes, sir. Minus 3 into what? Minus 15 minus 2. And what? This what? 6 minus 1. So this is going to give us 2 into minus what? Minus 9 minus 3 minus 17 minus 1, 5. Is that right? So this is going to give us 2 minus 18 plus 17 times 3. Sir? 17, 3, 7, 3, 51 minus 5. So let's add that. Minus 18 plus 51 minus 5. Eh? That will give us 28. So we have been able to get a determinant as 28. So since we're able to get that, we now want to find A. So for us to find A, we have to x, y, z. This line is for x. This line is for y. And this line is for what? Z. So when I want to find x, I will remove, I replace with the answers. I will do the same thing. Then, when I do that, I will divide this with that, I get x. But I want to get y, I remove this, I replace this answer there. I do the same thing, I divide with 28. The same thing applicable with what? So, let's start with x. We are starting with x. So for x, there's what we call change in x. I said it's called what? That, my friend. Change in x. Says change in x. Say change in x. So change in x will now be equals to, this line is for x, so I will remove that x. This line is for y, this line is for z. Those are where I get those values from. Right? So I'll remove that x, I replace that answer there. So that will now give us what? 4, 18 and minus 11. So my 3, 1, 2 will still be there. Minus 1, 2 and minus 5 will be there. That is what we call change in x. Because x has changed. So you now want to find the determinant of that. I call it change in x determinant. Change in x determinant. So the cofactor of this, in each of this we have minus 1 to the power of I plus j. See? So the cofactor of this will be plus, minus, plus. Because first row, first column will give me an even number. First row, second column will give me an odd number. This will be negative. First row, third column will give me an even value. So that's why it's always plus, minus, plus, minus. So, x determinant will now be you now have therefore into the row and the column is not needed. 1, 2, 2 minus 5. Are you following me? Now minus 3. This and this is gone. 18 to Is that right? The row and the column you don't need. You see the way we do the arrangement. Mathematics is very beautiful. Very nice. So from that point, we can now find the determinant of this, because this and this has formed a 2 by 2 determinant. So we are going to have 4 into minus 5 minus 4. Is that right? Minus 3 into what? Minus what? Minus 65. You know, minus is plus. But it's a minus of the determinant and the minus of this 11. We turn that place to 22 plus. Then 13 times 2, 26 minus into minus 11, that's plus 11. Please, if you want to stand this way. I'm plugging that camera is putting on this. So either you stand this way, or you sit. Don't always stand in this place like this. Camera is put. Energy. So, I'm good. We now want to find change in x determinant. Let me take it up. This is still flowing. The Spirit. But then you have the minus 3, minus 65 plus 22, minus 43. Let's do it step by step so that I will not do mistake. This is 4, minus 9, minus 3, minus 63 plus 22. That's the minus 43 there. Minus 1. That is 37. So, you now multiply 4 by minus 9. Eh? Minus 56. Minus is plus. Then 3 times 43 is what? 129. Minus 57. So the answer equals to 56. That is my change in x. Abi? But we are looking for x. So x will now be change in x determinant all over a determinant, because we call this a. We call this a, right? So therefore we want to find the value of x. So you now have to, after 4 hours, now we have this is 56 about 28, right? What do we have? You see all this long thing we go. Eh? So you have the same answer. If you do one mistake, you cannot have it. But must always speak the truth anytime. Right? So we still have to find the value of y2. The value of y, remember what I told you. Now when I want to find y, I will not touch x again, because when I was using change, my change in x, this place was x. Now y, I remove this, I replace that. I will call that change in y. So my change in y, my 231 will stay. Abi? I'll bring 4. Have you seen that? Minus 1, 2, minus 5 will still be there. So let me see, keep down 2, 3, 1. 3, 1, 2, minus 1, 2, minus 5. So therefore, we'll be able to get the value of y from there. So remember what I told you here, that we have to find determinant of y. We will find determinant of y. And that will be that my change in y determinant equals to, notice it's a plus, minus, plus because of the cofactor. Right? So you have 2 in the what? 13 to minus 11. Have you seen that? Minus 4. Three, 2, 1, minus 5. Because when we take minus 4 out, this and this non needed. So what we have is 3, 2, 1, minus 5. Then you take minus 1 down. The row and the column we don't need. What do we have? 3, 13, 1, minus 11. 3, 13, 1, minus 11. So at this point, we are going to multiply. We are going to multiply the 2 by 2 determinant, because it has done the 2 by 2 determinant matrix, right? So, when we now multiply So we multiply this with this, we have 2 plus 22, because a minus and a minus will turn up place to what? Plus, right? Last one. Are you with us? Coming up, my friend. The way you are smiling is as if you love mathematics. So minus 4 into what? Minus 15 minus 2. Is that right? So at that point we can now come back and have minus 1 into what? Minus 33, right? 11 times 3. Minus 3 minus 13. Is that correct? So this is going to be 2 into minus 5 plus 22. Minus 43. Minus 4 into minus minus 1 into minus 46. Hope you are following me.
Yes, sir.
So this is going to give you 2 times minus 43 is what? What is it? Minus 86. Minus minus is plus. And 4 times 17 is 68. Minus times minus give that place plus 46. So if you, this and this and this will give us 28. 28. 28. That is not y, but it is what? Change in y determinant. So for me to get y now, changing y determinant all over A determinant. That will be what? 28 over what? 28. And that will give us what? We have one already. That's the beauty of mathematics. That's the beauty of mathematics. So let's find the value of Z. Let's find the value of Z. So we need to find, in that case we delete so we have we want to see how we can get the value of Z. The same principle. So we still have to substitute the value of the answer to find Z. So in that case, when we now fix up that value, we are going to have Z. We are going to have Z. So we replace, don't forget I call that changing Z, right? So my 231 will still be there. Huh? What else? 312 will still be there. Now replace the answer there. Forward. And I'll replace my 418 minus 11. That is my change in Z. Then we now find determinant of that. The determinant of that Alright, so on this note we have that my change in Z determinant will now be, remember what I mean? Plus, minus, plus, like as usual, right? So when I now take my 2 out, what belongs to the row and the column you don't need, alright? So that place will now be what? 1, 18, 2 minus 11. Minus 3 into this and this, you don't need. What do you have? Are you getting me? Now, plus 4 into what? 3, 1, 1, 2. The beauty of mathematics. So at that point we have 2. What do you have here? Minus 11. Minus what? What is here? Minus 13, right? Plus 4 into what? 6 minus 1. So, this is 2 into minus 11 minus 26 is what? Minus minus 37 minus 3 into minus. Anytime I hear your voice, you give me speed in solving mathematics. Because we are catalyst that speed up the mathematical reaction. Clap for her. Now, this is plus 4. This was, this minus 1 is what? So, multiply 2 times minus 37. What do we have? Minus minus 74. Minus 3 times minus this. When you turn the place to plus, right? 138. Now plus what? Let's add up that. That will give us 84. So you see that what I have this called my change in Z determinant. Abi? But I'm looking for Z, not change in Z. So therefore I'm going to have so therefore Z will now be 84. Change in Z determinant all over A determinant. 84 over what? Divided, what do you have? Are you sure?
Yes, sir.
Very, very sure.
Yes, sir.
So, therefore X equals to what? 2. Y equals to what? 1. So you see that we've been able to get the value. Please, if you look at that critically, you can see that the corresponding value of X, Y, and Z, we have gotten it. Is that right? Is that correct?
Yes, sir.
So, I want to believe all of you understand what I'm doing. Last born. Be on your feet. Have you seen what I've done in the board? Do you have any question to that effect? Huh? Do you have any question to that effect? Okay. You have any question? All right, sit down. If you see very well, we've been able to get the value of x, y, z. Have you observed that? We get x, y, z in all the, how do you call it? In all the methods we are using. Mathematics is unique. All the methods we are using, we still get the same one answer at the end of the day. The same x everywhere is universal. The same y and the same z. Are you following me? So, please, what I need to also tell you is you need to be very careful. Are you hearing me? When you are solving math, you need to do what? Because if you do one mistake you do will affect a lot of things. So, we've been able to gain those answers very well. All right, please. Any question? This is time for interactive. We have interaction, we interact with each other, we ask questions so that we know mathematics the more. Yeah. Okay. Somebody's asking the difference between this method and Gauss elimination method. This one is grammar's rule, right? He said, what is the difference between this and Gauss elimination method? So what method do they use to solve Gaussian? Is it echelon? Is it echelon matrix? Or are you using matrix? In that method, Gauss method, we solve to get the results in the end. That we use the variable to apply matrix to get the result at the end of the matrix. Are you getting me? But in this other one, we just apply a very different ballgame altogether, finding the corresponding value of x, y, and z. Gauss method is a linked method that chain itself. But this other method is dividing itself into different parts. That when you want to find x, you find x separately, you find y separately, and you find z separately. Are you getting me? Let's another question. Another question. Any other question? You have another question? I'm not going to die here for you. Please, you have another question? Okay. So, we are still on the exercise of all the topics we did, because after this we are going to enter differentiation, which has to do with an integration. So let's still go on another question in the exercise that we left behind. You need to cross all the T's and not all the I's. I hope you are through with this. What do you say? You have many ease of service. Okay, so that everybody will go. Eh? But it's going to be everybody. Everybody will go in it. Alright, please, let's proceed. So we want to I can clean this up. So, I believe you are through with this. I want to clean it up. So, you see very well that from what we've just done, no matter the question that they gave to you, no matter the method you are using, so long as you do what is right, so long as you do what is right. So we're still on those exercises on the past topics we've done. We are going to solve exercise on the past topics we've done. This now on matrix, is a given the matrix. minus 5, 8 minus 6, 1. Now the question is, find M12, the minor 1, 2. The minor 1, 2. The minor 1, 2. It is a 3 by 3 matrix. It's a 3 by 3 matrix, and we want to find some questions that is attached to it. So first, the minor matrix is what we want to find right now. So find I minor 1, 2. Now, this is what we are doing here. When you go to, you are given matrix. We're going to a different matrix. You have the minor from minor 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. How do we do that? We obtain by removing the rows and the column of A, called the major matrix of A, denoted by that. So, example now, I want to find my M1 down here too. This is 1, 1, 1, 2, 1, 3. Are you following me?
Yes, sir.
What is it? Remember in a cofactor, A13, A21, A22, A23, A31, A32, A33.